video will walk you through how to use the Safe Operating Area Calculator tool for all Wavelength OEM products. We refer to the Safe Operating Area Calculator as the SOA Calculator. The blue line in the graph on the right is the boundary between safe operation and overheating the output stage. This represents the maximum internal power dissipation in the product datasheet. If that power limit is exceeded, permanent damage will result. The SOA calculator will take the design parameters you enter and draw a load line for your application. If it is safe, the line will be green. If not, the line will be red. This video will also suggest design changes that will keep the output stage from overheating. To access the SOA calculator, go to Wavelength's website and select Support Design Tools. Let's start with a temperature controller. Parameters are entered into the fields on the left side of the page. Mousing over the green field labels will pop up a definition of the data required. For this example, we'll select the WTC3243 with the best case thermal solution kit. This thermal option shows the constant power curve for the WTC's maximum 9 watt internal power dissipation. Most products will default to a heatsink thermal option. If the heatsink fan is integrated into the product, the heatsink capacity is already factored into the SOA calculation. If a heatsink is not included, you will need to provide it an adequate airflow. First, we enter the maximum enclosure temperature. If you don't know exactly what it will be, enter 50 degrees C to be on the safe side. If you can guarantee that the enclosure temperature will be lower, enter the known value. For this example, we'll use 50 degrees C. Then we need to enter the limit current. This is the maximum current for your application and must be less than the maximum shown in the thermoelectric datasheet. For this example, we'll use 2 amps. Next, we enter the equivalent load impedance for the resistive heater or thermoelectric. We approximate this by dividing the maximum voltage by the maximum current for the device. For this example, we'll use the thermoelectric, which results in a 4 ohm impedance. Finally, we enter the voltage for the power supply you will provide. For example, the WTC can use anything from 4.5 to 30 volts. In this example, we will use a 5 volt supply. Now press Enter or click the Find SOA Compliance button. As you can see, the green line is well below the blue boundary line. This design is within the safe operating area. Let's simulate an application that is not a safe design. In the previous example, the output current will never reach the full capacity of 2 amps. It will be compliance voltage limited because of the 5 volt supply. So let's increase to a 12 volt supply. You can see now we have a red line, meaning it is not a safe design. Some of the options we have to make this a safe design are reduce the enclosure temperature by increasing airflow or reducing ambient temperature. This works, but without any robustness or margin for error. Reduce the limit current. This works, but seriously limits the effectiveness of using a 2 amp thermoelectric. If your design permits, you can lower the power supply voltage. Again, this works, but without any robustness or margin for error. If you can choose a higher resistance thermoelectric, more voltage will be dissipated across the thermoelectric than across the controller. If you can't change these design parameters, or a combination of changes is not sufficient, you can consider choosing a higher capacity controller. For example, choose a PTC5KCH under these conditions. There is obviously ample capacity with this controller. As a last resort, add a power resistor in series with the thermoelectric to dissipate some voltage external to the controller. This is less than ideal because it is inefficient and you will hit compliance voltage limits sooner. If you do not use a heatsink and fan on the WTC, maximum internal power dissipation is less than 1.2 watts, as shown by this graph in the WTC datasheet. Note how much improvement results from adding airflow. Now let's look at a laser diode driver. The SOA design parameters are different. we'll select a PLD 5000. If the heatsink fan is integrated into the product, the heatsink capacity is already factored into the SOA calculation. For laser diode drivers, this is shown as a thermal option of none, because no additional heat sinking is required. For this example, we will assume it will be in the same enclosure as the temperature controller at 50 degrees C. We'll assume a limit current of 5 amps, which is derived from the laser diode datasheet. If you are using series resistance as a protection mechanism, enter the resistor value. Otherwise, enter 0.001 because the SOA calculator requires a non-zero value in this field. For this example, we will choose a 5-volt power supply. Finally, we enter the laser threshold voltage, which is the voltage across the laser when it is lasing. Here we use 2 volts. Now press Enter or click the Find SOA Compliance button. So you can see that the line is green, but comes right up to the blue boundary line, which does not leave much cushion. Some of the options to make this a more robust design include reduce the enclosure temperature by increasing airflow or reducing ambient temperature, reduce the limit current. If your design permits, you can lower the power supply voltage. If you can't change these design parameters, or a combination of changes is not sufficient, you can consider choosing a higher capacity driver. For example, choose a PLD 6500 under these conditions. This gives the same safety margin as operating the PLD 5000 at 4 amps. As a last resort, add a power resistor in series with the laser diode to dissipate some voltage external to the driver. This is less than ideal because it is inefficient. If you have a complete laser driver solution with integrated temperature controller, like the LDTC series, you need to calculate the SOA for both the temperature controller and laser diode driver halves. Choose the LDTC model in each version of the SOA calculator to independently determine that neither the controller nor the driver will be overpowered. This gives an overview of the online SOA calculator design tool. Our technical support engineers are available to assist with any questions about design safety.